I'll go ahead and introduce our panelists. So first off, I'd like to introduce you to the moderator of our next panel discussion, which is the future of manufacturing with digital technology. Michael Chui is a partner at McKinsey Global Institute, and he'll introduce his fellow panelists. Michael?
Great, thanks so much for spending some time this afternoon and for the sound coming on. We're going to talk a little bit about the future of manufacturing. I know a lot of you know a lot about this topic, but I'm joined by a terrific set of panelists here. My role at the McKinsey Global Institute, which is McKinsey & Company's research arm, is to do research on the impact of long-term technology trends. And certainly in our disruptive technologies research, we've identified a number of technologies which are impacting manufacturing going forward. And then in our broader macroeconomic research, we found, of course, lots of interesting things going on with regard to manufacturing activity moving around the world, but which, by the way, not necessarily along with jobs. So there are a lot of interesting topics to cover there. But let me ask actually my panelists to introduce each of them themselves in terms of a little bit about their background and what they're doing now. So Winnie, why don't we start with you?
Sure. My name is Winnie Yu. Actually have an engineering background. I have a double E from Carnegie Mellon, CMU PhD. Worked at Western Digital and SVTC Technologies. Went back for business school, back to the dark side, unfortunately, and then came and joined Flextronics Lab 9 last year.
Great. Patrick.
Good evening. Thanks, Mike. I'm Patrick Dunne. Background is industrial design engineering. I work for 3D Systems, which is the founding company of the 3D printing industry. Joined 3D back in 1998, and my role within the company is to collaborate with OEMs and engineering teams and designers within different companies, helping them identify, how to make things, basically, using advanced technologies, which include additive technologies. Okay.
When was 3D Systems founded?
The original technology was invented back in the mid-1980s by Chuck Hull, who's our CTO. He founded a company, I think about 87, 88, sold the first machine in 89, and the rest is history.
Right around the time of Knight Rider, I think. How many people have used a 3D printer? At Tech Shop, of course? No, at all? How many people have heard of 3D printing? Oh, that's pretty good. All right. Well, obviously 3D Systems is a leader in the field. Can you tell a little more? You said it was founded back in the 80s, which I was surprised that the technology's been around for that long. What's a little bit of the history of the company and the technology that went with it?
Prior to additive, there was really only two forms of manufacturing. There was subtractive, anything from chipping a piece of flint to make an arrowhead to CNC machining, everything in between. Formative, and casting copper, bronze, axes, all the way to injection molding. They're the two pillars of manufacturing. With the advent of additive, what differentiates additive from the two previous forms of fabrication is that there's really no limitation on complexity, right? So what we like to say is the correlation between cost and complexity is almost non-existent. And that's the game changer. And that, with the advent of the first printers in the 1990s, the first wave of adoption really was rapid prototyping. Not only can they build things that are very complicated, but they can build things very fast. So if you have an idea at 10 o'clock in the morning, at 3 o'clock in the afternoon, you could be reviewing your physical representation of your idea, which was a game-changing. So instead of taking 2 weeks to get a signal response from an idea, now you're getting a signal response in hours. So the rate of iteration accelerates. And the more generations you put between your original idea and your final product, and the more evolved that end object is, the more optimized it is. So all through the 90s, rapid prototyping.
Can you talk about the technologies that were involved? Because there were several generations
the original founding technology was stereolithography, and that's a non-contact, non-thermal, buoyant technology, very high precision, ultraviolet lasers curing photopolymers. Fused deposition modeling emerged from another company in the early 1990s. Out of MIT came indirect inkjet printing, so jetting binders onto powders in order to create three-dimensional objects. Direct inkjet emerged in the late 1990s, where you're directly placing voxels of material in space. that evolved into multi-material printing, where you're selectively capable of placing microvoxels of material in three-dimensional space to make multi-material objects. They're the primary technologies. Sintering has offsets, which sintering is another technology which emerged from out of Texas, and that's again a laser.
What do you think about Texas there?
Melting powders, plastics, nylons, glass-filled nylons, metals. I mean,
And what's the state of the art now? You mentioned multi-material printing. What?
The state of the art really is the workflows. Kind of the design. A lot of designers now are. You don't just take a CAD file that's designed and optimized for a conventional manufacturing process and drop it into a three-dimensional printer and expect to see a value, right? It's really when you understand that there's no limitation on complexity, and the designer designs an object from the ground up with pure functionality in mind. And that's so the state of the art is the products that people are making. We're seeing
Can you talk about a particularly complex multi-material product that could be 3D printed?
Multi-materials at this stage is still in its infancy, to be honest with you. I mean, there's gradients of materials, but they're all part of the same family. We're not printing a 100% dense cell phone with no internal voids and with battery materials and plastics and conductive materials at this point. But that's.
Are you making an announcement now when it's going to happen?
No, but I mean that's kind of the holy grail. That's where eventually things might get. But at this point, like what Elon Musk is doing, he showed his rocket engine on Friday. If you're into mechanical engineering and structural engineering, and if you read between the lines of what he's saying, they've CAD engineered in microcapillaries into the walls of that structure. And those capillaries, they're feeding the fuel through those capillaries, and they're extracting heat from that engine faster than anything anyone's ever done before, which
and
allows
that's being printed?
That's been 100% 3D printed, that out of Inconel in a laser sintering system. And that engine has 10 times the performance, size to propulsion ratio, power. It's 10x better, and it's 100 times the cost anything NASA or the Russian Space Agency has ever accomplished, and that's through utilizing three-dimensional printing. And that's one example. You see the same if you look at GE. You look at fuel injectors. They're running their engines, their LEAP 9 engines are running 200 degrees hotter. It's a 9% reduction in fuel consumption. And, when Chuck Hull invented a 3D printer, he didn't, write down a list of things that he was going to enable or things he was going to disrupt. He certainly didn't write down, make a jet engine 9% more efficient, or, the list. There's a huge list that we could talk about all day. But
so a remarkable set of things that your company is doing in terms of supplying the tools to do the manufacturing. Winnie, so you work for Flextronics,
Right.
which I think a lot of people would know as amongst other things, a local company in some ways, but a contract manufacturer, and yet you work for a rather unique part of Flextronics. Can you say more about what it is, where it came from, and what it does, this lab?
Yeah, sure. So I guess most of you know Flextronics is a large electronics manufacturing company. We basically build products for other people, so we don't build any of our own products. We build for a lot of the Fortune 500, so we're used to working with very large hardware companies. Within the last couple of years, we've been starting to see changes in the hardware landscape. So basically, a lot of hardware startups were starting to come to us for manufacturing, and being like the large multinational company that we are, we weren't exactly equipped to deal with startups. We're used to dealing with like the Microsofts of the world, for example. Things have basically been changing in the startup landscape. Like the same things that happened in software are happening today, so in hardware. So things like really cheap or practically free 3D CAD software, electronic software, 3D printing accessible to the average consumer. It's basically enabling average people to start inventing at the hardware level. And they were coming to us from manufacturing, and we're looking at them, we're like, you have to pass this credit check, you have to have $1 million in the bank, you have to have this full product development cycle. And obviously, startups don't have that. It's maybe 2 or 3 people. They have big dreams. They might have some cash in the bank. But basically, they have a prototype, and they need to be able to get to high-volume manufacturing. So we started Lab 9 about a year ago in order to really bring startups into the Flextronics ecosystem and help them bring their prototype to volume. So we help them with things like, we basically, like Lab 9 is basically Flextronics' hardware startup investment or accelerator arm. So we invest in hardware startups that are strategic to the company. So basically the startups that we look at, they have to fit into one of our business units. So that includes consumer electronics, medical, aerospace, defense, industrial, robotics, kind of almost, you name it, we probably build something in that sector. So we're more of a strategic investor in that way. But what we give them is cash, office space, and really the part that's the most important to them is engineering services. So most of the teams that we see, they have 2 to 3 people maybe. They're not exactly hardware engineers. They're mostly software guys with maybe some hardware tinkering experience. Like they've been makers in the past, for example, or continuing to be makers. And they have something that works, but they can make 5 of them. But once they get to the point where they make 5,000, 10,000 of them per month, there's a lot of engineering work that they need to go through that they don't actually have the expertise for. And that's why Lab 9 was started, to help them to get on that path.
How common is that? Because I've read, Lab 9 wants startups that have a working prototype. How tough is it to get from working prototype to production?
It's actually harder than most people think.
Harder than most software people think?
Yeah, definitely than most software people think. I mean, like, at least software, you can release a beta version, then do new releases on the fly, right? If you're going to build a hardware prototype, like you can 3D print something or make a board at a local mom and pop shop. But then if you're going to make like 5,000, you can't really use 3D printing necessarily if you want to make it at volume and cheap. So we have to go back to these traditional machining, manufacturing.
Let's see if Patrick
tools.
agrees with that. But
Oh, yeah.
Well, for certain things, like for us, for like machining metals or like doing like soft plastics.
Yeah, so one of the 7 or 8 things that 3D printing brings to the table, fundamentally, is what's called design flexibility. You can bring a product to market that's 3D printed, and as long as because you haven't committed to tooling, you haven't spent all your money on injection molding tools. Your data, your CAD file is effectively the tooling, right? So you can modify the tooling modify your component for 0 cost. Part B could be an evolved version of Part A. Part C could be an evolved version of Part B. We're seeing a lot of that now. Starting out, primarily in low volume manufacturing. If you need 100 of something, it's hard to justify tooling. Whereas with a 3D printer, the cost is a constant, irrespective of volume.
So right now that line is around ends of 100 or so.
No, it completely depends on the geometry. I've seen examples where for small little plastic clips, you could make 10 by 10 by 10, 1,000 clips for $1,000. The tooling would have cost $5,000. So in theory, you could make 4,999 units and save yourself $1 and still have the flexibility to modify your part on the fly and begin the process of manufacturing immediately, not having to wait a week or 2 for your injection molding tooling to come back and all the complexity associated with committing to conventional manufacturing techniques.
Winnie, I didn't mean to cut you off. So
Sorry.
there's a
Oh, yeah, no problem. Yeah, it's funny because all the teams that come to us, they have a prototype. It may be 3D printed, it may have machined it at a tech shop, for example. But then they say, okay, we're ready to make 50,000 of these every month. Then we take a look at it, like basically when I bring our engineering teams on board, they look at it for design for manufacturing. They're like, no, you need at least 6 to 9 months to a year's worth of engineering work on top of this, right? Because I think 3D printing is great for making maybe the first set, especially if you're doing a lot of changes at the very beginning. But if you're getting to the point where I want to be able to push a button and make 100,000 of these in a month, you really need to go through that whole, DFM, make tooling that will last for that many units. It's just getting from, the 100 to like tens of thousands is actually pretty hard.
So investors can't be very happy to hear that their timelines have to be extended 6 to 9 months, right?
Well, we're starting to see a little bit of a change in the investment landscape. People are starting to understand that it takes a while. It's definitely not like software. But they're also looking for the entrepreneurs to be reasonable, right? if people can say, oh, I can pump these out, 3 months, they're joking. Oh gosh, I hope they're joking at that point. But like if they give, if our entrepreneurs give us a timeline of like, well, we think we can do this within 9 months, a year, that's actually more reasonable.
So it's interesting. You said there are some ways in which these revolutions in the future of manufacturing are making it more like software, and then there are ways in which it still isn't like software, right?
Yeah, it's really that transition from the prototype stage, like where you could do the 3D printing, to when I'm going to ship this to China and build tens and thousands, hundreds of thousands of these. So you really need, that transition is the hardest part. And that's where you could, actually, you can make or break a startup. Lots of things can happen, like engineering problems, they run out of money, designs need to be redone. Maybe,
what can companies do to accelerate the transition?
Start working with the CM as early as possible. It's not just a advertisement for Flex, right? No, I mean, if they have a manufacturing engineer on board to at least consult with or talk to at the very beginning, it helps a lot. Just because, at least what I'm seeing, most of the startups that we have don't have manufacturing people on board. They typically go to the outside. They're generally looking for help. So having someone to kind of guide them along the way really helps them a lot.
Speaking of engineers, how many engineers in the room? A lot of them. All right, let's geek out for just a little while, all right? So you guys have both been trained and been practicing engineers. What's the coolest manufacturing technology you see in the next 10 years that you want to pay attention to?
I see 3D printing as a subset.
No, really?
I see 3D printing as a subset of automation. It's part of the robotics and automation and drones and autonomous vehicles. It's all part of the same thing. It's taking labor out of processes. I think the big next in revolution with respect to additive that interests me is home construction. I think if you look at the act of building a house, it's largely a complicated, labor-intensive project. Most of the costs are associated with labor. Most of the confusion and complexity and issues and management, it's all about these humans crawling all over that structure. I think that it's low volume. You need one. It's complex. It's manifold. I think that 10 years from now, 20 years from now, I think the idea of making a house by hand will be ridiculous.
You're going to print a house?
It's happening already, and I don't see why not. Yeah, absolutely.
It's happening already. What does that mean?
There's a bunch of folks around the world who have demonstrated building houses, walls, rooms. You put down a railway track, a X stage, a Y stage, an extruder. You're extruding concrete. You're drawing two-dimensional. By the time you come around, a concrete set, fast-setting concrete. You're adding complexity. You're building in all the ducting and air conditioning and services, and there's no limitation on complexity, right? So and it doesn't matter if it takes 2 or 3 weeks. You set up this system, you press play, and you select what house you want on your iPhone, and you press go, and come back 3 weeks later, and it's ready to be painted, or maybe the robots have painted it. I don't know. But that's the future of construction. I see that across the board with truck driving, and just everything is ripe for automation. Law, we talked about that.
Winnie, from a technology perspective, what's exciting to you?
I guess there's technology and there's also the users, right? Basically, I'm seeing a lot more people getting involved with the design side. So you're getting a lot more creative ideas at the very beginning. So I could just imagine, if you get everybody involved, it's kind of like you're almost democratizing the whole design phase of productization with all the new tools that are out there, including.
So what does that mean? Who can design now that hasn't
like
been?
For example, like if you look at Quirky, right? Basically anybody can become part of their ecosystem and or their community. I think that's what they call it. And you can put in an idea for them. It's more of like home goods, things like that. It's home consumer electronics kind of goods. Put in an idea for something you want to build. It goes out to the community. People will add in features like, I'm an electrical engineer. I think you can add this to it. Or I'm a mechie, and if you round this corner, it'll be easier to build. Or I I work with kids every day, and this is how I think they would use it, and then if you put this other feature in, then it'll be easier for them to use. So because you're basically making invention accessible to everybody, you get a lot more ideas thrown into the mix.
What's the coolest thing you've seen on Quirky?
Personally, they're really well known for their power strip. That's like the one that bends in all the different directions. I personally like the, what was it? It was like I like to cook, so the egg yolk separator thing. It kind of looks like a basting, like an egg yolk suction thing that takes out the egg yolk. But you know, that was done with a couple of industrial designers. Home cooks got into the fray in the community. So that may not have been something that, you know, your typical kind of home goods designer would make if you didn't have the input from like someone who bakes a lot, or I guess someone who extracts egg yolks a lot, until you actually throw them into the community.
So it's actually the theme of this conference, right? It's manufacturing, about particularly being open, shared, and democratized, right? And you just suggested a way in which that's actually starting to happen. What are the, and you know, obviously 3D printing is again, another way in which it's making the tools of production available, right?
It's another tool in the toolbox.
Yeah, right, and tech shop, you know, there are you know, firms that also, from a commercial standpoint, are making, you know, the tools of the Industrial Revolution available at very low cost. What are the implications of democratizing design, democratizing the ability to produce, creating the ability to do mass custom manufacturing? What does that mean in terms of you know, the design community? What does that mean in terms of competition for large companies?
I mean, you ask several questions here. I think,
Well, let's start with design.
I mean, I personally believe that you know, democratizing access to design. It's like if you give everybody typewriters, doesn't mean everybody can write a novel, right? Although if you did give everybody typewriters, you will find the folks who can write novels, or the probability of finding them is increased, right? So it doesn't make everybody a designer or an engineer or, you know, have any particularly new skill, but it certainly increases the pool of folks who are entering those particular industries, I think. So.
How do we find the people who can write novels as opposed to the people who?
Oh, maybe it gets kids interested in engineering and building products at an earlier age, right?
Absolutely, yeah.
It's the next generation of engineers.
Anybody have making these types of tools available to their kids? Maybe more people should.
No, I was telling Mark earlier, he was 7 at the time, and a boy at home, and I taught him how to use Rhino CAD to draw stuff, and he was getting frustrated. You know, he'd draw for half an hour, and I'd come back, and he was bored of it, because all he would ever get to was a picture on a screen.
Yeah.
You know, he's rotating it around, rendering it. He was boring. Plugged a 3D printer into it, and reignited his interest. Wow. It was like putting, you know, accelerant on his creativity and his entrepreneurial spirit. He started like making little accessories for Lego characters and selling them at school. And the next thing he's like, you know, a budding entrepreneur at like 8 years old. You know, cornered the Lego character market at 2nd grade. You know, so but that's, you know, it's you know, I think it's a powerful tool. I personally think that every single high school in America should have access to a 3D printer in their, you know, tech shop. You know, I think if we wanted as a country, at a federal level, as a policy level, if we wanted to, you know, sprinkle something onto society that would increase the entrepreneurial spirit, I think it's like giving, like, you know, what Apple did in the 1980s, give every high school a computer, and it's no coincidence that these hotbeds of algorithms, you know, generation emerge in those regions. So I think the hotbeds, you know, this country its entrepreneurial spirit could be ignited. I think we'd see a response in the 10 to 15-year time frame if we give folks access to these kinds of tools.
Well, certainly there's the role of the entrepreneur. There's also the role of just being an engineer. And Winnie, you had talked about a potential concern, at least, you know, in this country, about whether or not we have the type of manufacturing talent we need. And, you know, maybe, you know, the front end of the pipeline is something we can solve for. But can you say more about what you meant by that there might be some challenges on the talent side there?
Oh, yeah, sure. So because we have our local factory in Milpitas in the south, which is actually really close to here, we actually work with a lot of the local government initiatives on manufacturing locally in the South Bay. And I remember going to a round table. They had manufacturers, business people, educators, all in the room, and we were talking about how can we increase the talent pool in the South Bay for manufacturing. And one of the things that came up was how do you get kids involved? Nobody wants to build things anymore. I mean, it's kind of funny. I'm encountering people just slightly younger than me who've never actually tried to work on their cars necessarily. You know, just like little things like leveling the thing under your fridge so that it sits straight. It feels like kind of my generation, just kind of younger, we've kind of lost that ability to work with our hands to some extent and understanding how physical things work. Everyone wants to go into software, right? It's easy. You get it's almost instant gratification. You write some code, you know, it says hello world, right? Or you can create an app. You can create a company that creates this app to sell on the App Store. Maybe you earn $1 an app, something like that. But as a result of that, I don't see a whole lot of people going to mechanical engineering, EE. At least at my level, I see like a 15 to 20 year age gap between the engineers. At least when I started working as an engineer, everybody was at least 15 years older than me. And then at my level, there was only maybe like a handful of engineers just entering the company.
What's the solution for that now, right? We can get kids who are 3D printing things
getting
now.
them interested. It's not just about software, right? That software has to run on something. And you know, you're finding, the other thing I'm finding is that people are more likely to draw an emotional connection to an object versus in a piece of software, for example. Like, how well connected can you get to your Angry Birds, right? But like, you are pretty connected to, say, like your watch. It doesn't even have to be like, you know, a smartwatch, like just even your regular watch. You miss it if it's not on your wrist, because there's a physical connection there. And, you know, if we're not gonna have, I mean, there's ways around getting the talent pool, but if the domestic talent pool is really not interested in building things, because they haven't been exposed to it, or just simply not interested. I mean, we used to have wood shop when I was a kid. I don't know how many of you guys remember that. But nowadays, it's all like, let's go to the computer lab. Let's go write some code. So there's like the whole physicality of building things is just, it's kind of going away at some level.
Although Mark had a lot of inspiring stories about people who have gone to tech shop and decided to build things.
I'm really glad that the maker movement's coming up, or it's been around for a while, actually, because it's really getting people interested in building things again.
Yeah, terrific. I'm curious, you know, Winnie, you mentioned a little bit about, you know, some of the potential U.S.-based, you know, questions, but if you expand this more globally, if you think about what these technologies enable in terms of being more open, in terms of sharing, in terms of being, you know, making the means of production more available, you know, what does that mean globally if you think about emerging markets, if you think about, you know, other countries in different places? Patrick, you know, your company is global, and so.
I mean, I think there's two things going on. One is, you know, the Industrial Revolution left the United States and migrated around the world, chasing cheap labor. But automation, you know, Foxconn is replacing 250,000 workers with robots. Globally, we're faced by the same problem, right? Where, you know, anything that's manual labor is basically going to be disrupted by automation. What the other side of that is that we are seeing companies returning to the United States to make things locally, right? A robot working in China or robot working in, you know, Tesla, it's just the cogs are the same, right? It's in fact you reduce costs because you now don't have to ship something across the Pacific Ocean. You can make it locally. Mind you, you know, if you go into GM in Detroit and you walk into Tesla, they're configured completely differently. One is very human dependent, and the other is very much highly automatic, highly optimized. But he's building cars in Silicon Valley, and GM can barely make them in Detroit. I mean, that's remarkable. That's a function of automation. So,
Winnie, you've mentioned that Lab 9 is not just here in Silicon Valley, but in fact, you have a role that spans across the globe as well. Can you talk a little bit about what's happening around the world?
Yeah. Well, basically, So Flextronics is multinational. We have offices in 30 countries. So when we look for startups, we look around the world. The majority of the hardware startups that we see are based in the U.S., but we're seeing pockets show up where there's been some hardware base, but not necessarily a whole lot of entrepreneurial spirit and innovation until more recently. So we're starting to see hardware startups in Japan, Singapore, Taiwan. You're starting to see, it's kind of funny, I feel like the large cap accelerator is now the new buzzword because everybody's opening up an accelerator. So there's one in Kansas City for Sprint. There's the Nike one. There's pockets, and basically for us, because since we're multinational, we try to source from everywhere, and we it's funny because we were talking about our teams being very multinational. So I might be based out here, but then my startup's based out of Atlanta, and then we've got a mechanical engineer out of Ottawa and a double E from Austin. And program managers from San Jose, all working together on the same team. We are I haven't had any more recent projects that require it yet, but we have had some teams that worked with the Singapore and Shenzhen sites. We're still getting all of our talent internationally, but then all the manufacturing is being more regionalized instead.
Distributed.
Yeah, it's basically distributed.
Yeah, it's interesting. Hal Varren, who's the chief economist at Google, sometimes calls these companies micro-multinationals, right? They're born multinational. Is it harder to have a micro-multinational, though, when you're trying to manufacture, or have things become easier because of digitization?
For us, I don't see that big of a difference. Well, at least because the factory here is one of these low-volume, high-mix sites. So so our factory here is that way because all of the design companies are out here. So what we do is that we do the quick turns on the prototypes in low volumes, and by the time we are ready for high volume, to do a copy exact over in China. So it's still made in China, but that portion up front where all the innovation has to happen, so you get all the bugs out and things like that, all the process problems out, so you can make a bazillion of these things. That's when you ship it out to China.
So that's an interesting advantage, right, of being part of your global network of manufacturing, right? Even though you can learn to do it here, you can move it elsewhere if you need to.
Right. You don't have to go to China to begin with.
Yeah.
That's what a lot of people say, but there's so many resources here. There's no time zone change. Everyone speaks the same language. There's actually a wide network of mom and pop shops in the valley that do this kind of stuff. They're not as well known and probably not as densely populated as in Shenzhen, but they're all here. And for some of the engineers and startups that are out here, it's way easier for them to stay here and do it.
Mm-hmm. So it's exciting to hear about all these ways in which you're able to democratize design, make the means of production more available. And what are the barriers or obstacles to keeping that from really scaling up, right? I mean, tremendously inspiring stories from Mark and you all in terms of what people are able to design and produce. But to be honest, right, I mean, while each of those stories is individually inspiring, most of the things that are produced are designed by big companies, manufactured by big companies in large quantities. What are the barriers to actually seeing more of this, more open design and manufacturing occur?
I mean, there are always going to be efficiencies of scale and brand, for example, marketing budgets and getting product out into the market. You might have a little tiny startup that produces a better pair of headphones than Beats, but guess what?
That might not be hard. But
exactly.
Sorry, audio comment.
For now. But yeah, I mean, I think that's the biggest. Ultimately, that's the biggest challenge. Is that it's not so much technology and the means of manufacturing and democratization of design. It's all the stuff that comes after it. There's mechanisms that sales channels and marketing. And
I'm interested to push you a little bit, though. I mean, at one point you said, look, it's 1,000 monkeys can go and get typewriters, but they're not going to produce a novel.
Unless they're given enough time.
Yeah, we're throwing thousands of typewriters out to lots of monkeys.
Yes.
Right?
Yeah.
What is the mechanism that we actually use then to find the designs that are actually going to be?
Well, it's natural law, isn't it? I mean, the good ones come to the surface and the bad ones die.
So the market will find.
Yeah, of course.
Yeah.
Yeah. I mean, ultimately, it's fundamental laws, right? It's they have to deliver value. They have to, and usually delivering value is a function of solving a problem or satisfying a need. So it's basic stuff. I mean, and I think it's always been that ratio, right? I mean, there's 1,000 startups and 900 of them fizzle, 80 of them fizzle for a few years, and 20 of them.
Yeah. Winnie, what's going to keep these technologies, this trend from having even more impact?
Well, I guess my perspective is it's a little bit different because I work at Flex, so I get to see the large company bureaucracy and how hard it is to innovate on our side. And I get to work with the startups all the time, so I get to see all the amazing, great things that they're doing. And I have this hard job where I'm trying to mesh the two. So those of you that work at large companies, you know how hard it is to innovate, right? If your idea is slightly different from what the rest of the company does, it's really easy for it to get squashed, even though, in 10 years from now or even 5 years from now, that idea could have, changed the course of how the company has gone. Like, I like to bring up Kodak as the example.
Yeah.
All right, Kodak thought of themselves as a film company. So when film went away, Kodak has been around for a really long time. They went under just not that long ago.
Completely disrupted.
Yeah, exactly. Basically, digital cameras came in, completely disrupted the industry, and now Kodak's gone. However, if they had thought of themselves as an imaging company, I think they did to some extent. They would have changed it. They had digital cameras.
They invented it.
Yeah. They did all that technology, and yet it was so different from the core, focus of the company. It just basically went away and died. On the other hand, I get these startups and lots of great ideas. Like, I get 10 of the same kind of idea every other day, roughly. That's kind of exaggerating, but 10 companies doing better hearing aids or better headphones, things like that. And everyone's getting funded on Kickstarter or Indiegogo, or there's actually even an abundance of crowdsourcing platforms or crowdfunding platforms. What I'm seeing there is lots of interesting ideas and products, not exactly great business models that are sustainable. And some of the companies come to us and I'm like, I love this product. You guys are not going to survive beyond 2 years from now until you figure out what you guys are good at besides making this one product and creating a business from that will scale in the next couple of years.
So get ready with your questions. I'm going to come to the audience in a short time. But Winnie, you had mentioned large companies, right? And to a certain extent, these trends are ones that enable individuals, smaller companies, startups, et cetera. What do these trends around more democratized manufacturing mean for large companies? How should they think about it? I'll come to you, Patrick, afterwards.
I wouldn't necessarily see them as something that will go away. Like, as speaking as a large company, I would not look at a startup and say, oh, those guys they'll go under in 2 years. If it's really interesting technology that is actually useful to a large company, you could theoretically incubate it. It's actually easier to just go out and buy that company, and that's what we're seeing. So for Lab 9, the startups are my customers, right? But the other side of the equation, our large, Fortune 500 customers are also my customers. So where they can't innovate, I try to connect them to the startups that have the technology to bring it in-house with them. So they could do M&A, they could just license the technology. It really helps both sides at that point. Like, they don't have, the large company doesn't have to innovate on their own, where it could get squashed right away, and the startup gets to survive and really build a business from that.
Patrick, what does a big company do when they see things like all that cool stuff coming out of Tech Shop and stuff that Lab 9 is funding? Yeah.
Often, you mentioned that one solution is big companies acquire these little startups, but often that it suffocates the character of the entity that they acquire, and it just dies anyway. But within a big company,
Yeah.
You know what I mean? So it's a really good question, to be honest with you. A lot of the biggest companies in the world started out as tiny little startups in garages, right? Look at the Googles and the Apples and stuff like that. When it comes to disruption and something emerging that's going to put Kodak out of business, I personally think what it boils down to is individuals, usually CEO or senior members of a company who lack the ability to comprehend what they're being confronted by until it's too late. So it's largely personality and technical competence that kills some of these entities.
So replace CEOs, that's the solution.
Well, no, not saying replace CEOs, but it's often within these big companies, like within Kodak, there would have been hundreds of folks who would have said, this is the future, we need to do it, but the guy at the top didn't get it, clearly. You see that over and over and over again with big companies. It's almost like they're in this, they're in a bubble of, they're secure in their top of their empires, and they don't realize that they can be destroyed just like that.
That being said, you were telling me, how old is 3D Systems Chief Technology Officer?
How what?
How old is he?
I don't know what age he is.
All right, never mind.
He's older than me.
All right, let me go to the audience. Are there questions for our distinguished panel? Anything out there? Otherwise, oh, there we go.
Hi, good afternoon. I have one question for Winnie and one question for Patrick. Is that okay?
Yeah.
For Winnie, since Flextronics is a contract manufacturing giant, one of the giants, I just saw from the press that even Walmart, in spite of his willingness to bring back the manufacturing to the U.S. shore, and they have difficulty because they try to, instead of outsource, they call it, I think, offshore now. But then they cannot find a company that can support their products in manufacturing. So my question to you is, in spite of 3D system, 3D printing, and test shop, and crowdfunding, whatever, what is the future for the U.S. Manufacturing? Are you positive on that? U.S. will overcome that, or U.S. because it lost the manufacturing base, it will have a difficulty in getting back, at least for some time? I just want to have your take. Thank you.
Sorry, and your question for Patrick?
Is there both of us?
No, just this one is for you, but the next one for Patrick is there's a lot of hype about 3D printing and especially bringing to the consumer. As an engineer, I think it is not cost effective because just looking, I visit a lot of 3D printing companies. There's so many of them now, and the cost down to even $500 or $1,000, right? My question is, I think the material is not cheap. I mean, all you make is fingering or something. So is that too much hype, or I can hardly imagine that the 3D printing can make a lot, like I think G or someone make the jet fuel nozzle with 3D printing. I mean, it can have such a high tolerance and reliability. I just want to listen from the horse of the mouth, the mouth of the horse. I'm sorry.
All right, let's start with Winnie. Winnie.
Okay. Yeah, with the whole thing that for offshoring that's been going on the last 20, 30 years, with everything that I'm seeing here, we're actually increasing manufacturing in the U.S., but it's going to be different from what we were used to it being. So, the factory here in Milpitas compared to the factory in China, huge difference. Like if I go to the China factory, a lot of manual labor, right? Over here, everything's being done by a robot. We were talking earlier during lunch, I go to the line, there's one guy at the very front end of the line setting it up, putting in materials, and then it goes through a bunch of machines, and at the other side of the line, there's a guy taking out finished product. Because we're automating a lot of the manufacturing processes, a lot of highly skilled, basically operators, engineers, process engineers, many of them actually still reside in the US. A lot of the designers get very involved as well. So anything that's kind of either high reliability, anything high precision, highly automated will come back. I mean, we're already starting to see, picked up orders over here, especially in this area. We have more orders than the factory can fulfill right now. So it's coming back. It's going to be different from what we're used to. It's not going to be people assembling things on a line. Mm-hmm. It's going to be robots doing it instead.
I think that's one of the reasons why the economy has recovered, but the unemployment has remained pretty static because of automation.
Patrick, hype or
Yeah,
reality?
that's a really good question. So, I mean, really good comment. So the emergence of pop culture, 3D printing, with the expiration of the FDM patents and the emergence of MakerBots and cubes and all these 250 different types of little plastic squeezing machines. A little bit of a double-edged sword. On one side, it's positive because it introduces folks to the concept of making things by adding and making complicated geometries on demand quickly in a distributed way. But the other side of it is that those printers are really just toys, right? They're very low tolerance. They're fused deposition. They're not even welded. They're mechanically very weak, very limited range of plastics. So you have a huge number of people who that's their view of 3D printing, and what they don't realize is that that's kind of the hype and the consumer and then when folks get printers, they're disappointed that the Lego brick that they printed doesn't fit on their Lego brick because of the accuracy, and then it breaks, and their view of 3D printing is tarnished. But that's just maybe 2% of our business. The 98%, which is the industrial side, which is, like I said earlier, we make all the hearing aids in the world. From 1999, all hearing aids were made by hand. In 2001, every single hearing aid was made in our machines. Okay, and that's direct plastic stereolithography systems with biocompatible resins. Full adoption. It was like going from analog camera to digital camera. So, it's almost like the reality. If you extract the reality from the industrial side, which you never hear about in the press, or you never read New York Times articles about the future of 3D printing. The journalists are so disconnected from what's actually happening on the ground that they're not even aware of what's going on the industrial side. That it's like the reality in the industrial side exceeds the hype that you read about from the consumer side. But I think slowly but surely people are starting to see it pop up here and there. I mean, it's contacting everyone around you, whether you realize it or not. Invisalign makes 100,000 plastic, orthodontics, dentistry, anything that conforms to the human body. Most metal parts in the world now that are derived from, like low-volume metal parts that are derived from castings. Tesla in their cars. GM, all the cars that GM makes, while they're waiting for the tooling to be made, with long lead time articles like injection molding tooling, they use 3D printing to make their plastic parts initially, and then as soon as the tooling is ready, after 6 weeks to 6 months, they start to substitute in conventionally manufactured parts, and that's called bridge manufacturing. And they use selective laser sintering of nylons to bridge the gap between the car needing to go to market and the long lead on the tooling. And it's all around you, but you just don't see it. Nuclear power stations are more efficient. You can just go on and on.
Just for fun, and for those of you who are interested in the consumer version, there's a blog out there of 3D printing disasters, right? And so there are people trying to print their heads, and they go off like this.
But that's not really 3D. So like the MakerBots, the cubes, even our products, the cubes, and these little plastic. It's really toys, right? It's like somebody who's traditionally done mathematics on a piece of paper, and they discover an abacus, and now they're writing blogs about computers. And they've never seen a computer, right? It's like comparing an abacus to a supercomputer. And commenting, saying, well, they're slow, they're made of wood, the paint comes off when my kid chews it. It's like, what are you talking about? You're talking about a cube or a 3D, like a toy. Okay, no, this is where it's at. But in the media, when you open a newspaper or magazines, I read recently a blogger, his comment was, 3D printing is a cool technology looking for an application. And I was like, where were you in the 1990s when we saw massive adoption into the industrial applications? It's remarkable. But anyway, I'm sure the reality will eventually get to the surface. And,
I mean, maybe I can talk about it a little bit too, because we manufacture a lot of these products that you have in your pockets, for example, for phones. I mean, you're not going to 3D print your own iPhone, right? We're not anywhere close to that. I don't think that's going to happen anyway anytime soon. But not everybody wants exactly the same phone. And I'm not even just talking like an iPhone versus a Galaxy versus, a Moto X or something. A lot of people are interested in customizing the parts that matter to them, which is really the outside. So we have these factories that, mass produce cell phones, but however, people can put in a customized order like, well, I want the outside to be engraved with this and this color. Some of it's 3D printed, some of it's, laser etched. But we're talking about the ability to personalize some of the, mass-produced electronics out there. And that's where these sorts of additive processes can come in on top of the scaled-up volume production.
Yeah, there's three primary applications for industrial. One is like on mass production scales. One is mass custom manufacturing. So if you look at hearing aids, if you look at aligners, crowns, braces, scoliosis braces, anything that conforms to the human body like that is mass custom manufacturing. What GE is doing and is the first real example of mass complex manufacturing. It's where they're making the same object over and over again, but they have exquisite complexity, which increases the functionality of their product. And where we're going, and what part of what we're focused on now for the next 5 years, is we realized recently that a 3D printer doesn't care if a part's custom or if it's complex. It just makes it. And if we can make the printers fast enough, if we can make the printers faster, then the cycle time, so if we can make the units coming out of a 3D printer faster than the units coming out of an injection molding machine, and we can process materials that are equal or greater than injection molding thermoplastics, then we can disrupt the injection molding industry. And that's how 99% of parts are made. And that's our primary objective. And there's absolutely no reason why we can't do that with large array inkjet systems, and maglevs, and high-speed jetting, and make 50 by 400 batch in 1 hour, 10 times faster than injection molding. Direct from a CAD file, locally.
That would change things.
Yeah, so the tool and die industry, injection molding, all that, the companies that sell thermoplastics into open injection molding systems, the BASFs, the Bayers, all these guys, that's all going to change here pretty quick.
Yeah. Other questions from folks in the room? There's one over here and one over there. All right, over there.
Sure. I was just wondering, I want to say thanks a lot for coming along. It's been really interesting. Any thoughts about intellectual property rights for sort of additive manufacturing and digital manufacturing, where it becomes very easy for somebody to copy, make an identical product, essentially?
It's a really good question. I can answer that. There's a lot of debate about clever people spending hours thinking of ways to somehow imprint a CAD file with some string of code that will make it not replicate. So it's not printable, not compatible, like the watermarks that they have in some of the dollar bill data and stuff like that. But I've attended some conferences on this very topic, and it was hours of debate. And then at the end of the day, if you have a physical object, you can scan it. Right? The demonstration we did was Philippe Stark, the lemon squeezer. It's like he sues everybody. It's like Disney. Anybody replicates it, they're in trouble. Goes after them, no matter where they are in the world, and won't share the data, won't share the CAD file, the STL file. You can take an iPhone now with a scanner from Autodesk, and you can scan Philippe Stark lemon squeezer, and you can print it in your garage or in your workshop, and Philippe Stark's never going to know about it. Right? How can you stop people? It's not like it's like photography. It's not you can walk into a museum and take a photograph of a painting. They can't stop you. So,
Great, there was a question here, and then there was one over there, I think, too.
Yeah, I also want to say thank you to this panel. That a lot of new ideas really surfaced. A couple of questions, one for Winnie and the other one for Patrick. So I'll start with the question to Winnie. The manufacturing base has been based on, the new manufacturing for 21st century has been based on automation plus precision. However, that means for the ordinary high school kids or high school dropouts, except Bill Gates, Steve Jobs and those kind of people.
Bill Gates.
They could not get into this manufacturing because automation, that requires computer skills. And precision, I mean, that requires mathematics plus statistics and plus big data analytics. I'm not clear how this thing would be sustainable if we are looking at the education system in America, that a lot of our high school kids will drop out before they will ever even reach a senior year. So would you care for sharing some of your insight into that? Because,
And quickly, what's the question for Patrick?
Okay, the question for the Patrick is for any industry. What is the core competency for the 3D printing industry? Because I see, I mean, the innovation would be one of the core competencies. So you can take advantage of the 3D printing system for rapid prototyping. However, innovation, I'm not clear how that can be taught in college. For example, like a Department of Innovation Engineering, I don't see that coming.
Yeah.
Okay. Winnie?
Okay. Well, I'm not exactly a public policy maker or anything, but I am a product of New York City public school education. So I'm a big believer in that people are able to adapt. Yes, we are cutting out a lot of the kind of unskilled labor force out of the manufacturing portion. But basically, it's hard to say. I guess the one thing I can say is that it's up to policymakers, it's up to businesses, it's up to the local community to really work together to do something about it. I'm speaking on behalf of Flextronics. We can do as much as we can on our side. Like we try to fund educational programs, math, science, for middle school to like high school kids. We try to retrain our own employees as well. There's a continuous education process on our side because we work with factory operators all the time. And we know what's coming up, so we train them so that they can do the next level of job once all the manual stuff is cut out. So, I mean, that's what we try to do as a company, but this is a problem much bigger than something Flex or just even the people in this room can do on our own. So we really need like everybody else on board. So educators, government, I mean, that's kind of a hard one to bring on board sometimes. But people know about it. It's baby steps.
But we can do things. There was just an election yesterday, right? Patrick, what's the core competency of a 3D printing company?
So the core of a company or individuals who engage with 3D printers?
I believe the question was about the company.
Of a company that purchases a 3D printer or a company that makes a 3D printer? Or
Makes a 3D printer.
with high technology. I mean, I think there's a bigger question here, which is what folks are successful with 3D printers, I think.
Okay.
I mean, the companies that make 3D printers are high technology, standard mechanical engineering, electrical engineering, software, materials. The core competency with respect to folks who get the most out of 3D printers, what I find tend to be people who have the least experience with manufacturing, right? Because it's often you give a 3D printer to somebody who's been designing for manufacturing for 20, 30 years, and the rules of how you design for manufacture are so ingrained that it's a real struggle for them to break those rules, right? They draft angles and wall ratios, and it's just they're hardwired. It's calcified in their brains. And then you take somebody fresh out of college who's naive, who has limited experience, who's never been beaten down by the senior manufacturing engineers, and you tell him to design something, and he designs an object with pure functionality in mind, and doesn't compromise its functionality in order to make it economically viable to fabricate, and you get these really interesting designs. And that's my observation, is that some of the best engineers are the least experienced.
So I like that, inexperience as a core competency. All right, let me finish with a quick rapid-fire round of lightning round of questions, right?
They don't know what they don't know.
No, it's terrific. All right, Patrick, what types of manufacturing products do you follow now that are interesting to you?
I like rockets and electric cars.
Winnie?
Medical devices, quantified self.
What's the coolest manufactured product that you've seen come from a not big company affiliated designer? Winnie?
I'll have to pass on this one.
Patrick?
No, I can't think of something right now.
Where do you get your best information about the future of manufacturing?
Make it up.
Winnie?
I walk to the factory floor. No, we have an advanced engineering group that helps develop new technology for manufacturing.
What's the biggest challenge facing the future of manufacturing industry, Winnie?
Talent.
Patrick?
I think feedback mechanisms, right? Just nobody's working anymore. They don't have any money. They can't buy any of the crap that the machines make. So.
If you were going to college today, what would you major in, Patrick?
It's a good question. Design,
Winnie?
engineering.
Yeah, probably design or mechanical engineering.
In what country would you look for the next generation of manufacturing innovation, Winnie?
US?
China.
In tweet form, what advice would you have for US manufacturing?
In tweet form?
Yes. 140 characters.
I've never tweeted in my life.
All right, hashtag never tweeted. Winnie,
What was the question again?
what advice would you have for US manufacturing in less than 140 characters?
Continuously disrupt yourself to stay ahead of the game.
What advice would you have for Fujitsu? Winnie. They want to know.
Continuously
Yeah,
disrupt.
continuously disrupt yourselves.
Patrick,
Same.
in what manufacturing-related private company would you like to invest, Patrick?
Private company.
Yes.
I'd have to think about that, sorry.
Winnie.
I think we've already invested in them, actually.
All right, the portfolio. Yeah, I guess you're an investor.
Yeah.
What would you like to design and build that you haven't had time to do? Winnie.
Well, probably more like I'm more into like medical design, so biofeedback systems. Yeah.
Patrick.
I'm actually working on so many things right now that none of them emerge. I mean, everything
Pick
from
one.
lungs.
Lungs, okay. If you were to start a company tomorrow, what would it do?
Build houses using robots.
Paint houses using robots.
I think we have a business starting right now. And finally, what would you recommend to someone who wanted to learn more about the future of manufacturing? Winnie.
Visit a factory, see how cool it is. You'll get inspired.
Patrick.
Buy a 3D printer.
Please thank our panel. Thank you.